How's it going? So in this video we're going to talk about the basics of adding resistance in series and in parallel in order to calculate our equivalent resistance. Okay? So let's start by drawing a simple circuit. Okay, so we drew our basic circuit, and on the left side, you can see our voltage drop across the circuit. You can see our current and our two resistors connected in series. Now, when calculating equivalent resistance, our purpose is to be able to create a circuit that we can analyze easier. Now, this is just getting rid of one resistor, of course, but this is applied way more often when dealing with far more difficult circuits. So this is our goal. We are to create a equivalent circuit model. Okay? Now when we're adding resistors in series, all we are doing is our equivalent resistance is equal to resistor 1 plus our resistor 2. Right? So, example. In this circuit, let's say we have a voltage of 10 volts. That's our voltage value. Our resistor 1 is equal to 2 ohms, and our resistor 2 is equal to 3 ohms. Okay, so in order to calculate our equivalent resistance, we're going to set our equivalent resistance equal to 2 ohms plus 3 ohms, and that's going to be equivalent to 5 ohms. Okay? So, we know Ohm's law, and Ohm's law states that our voltage drop is equal to our current multiplied by the resistance. Okay? So, from this formula, we can deduce that our current is equal to our voltage drop across the circuit divided by our equivalent resistance. Okay. So, from here, we can input our known values. 10 volts divided by our equivalent resistance of 5 ohms is going to be equal to 2 amps. So now we know our current is equal to 2 amps. Very good. Now let's do the same thing, but instead of putting the resistors in series, we're going to put the resistors in parallel. When adding resistors in parallel, it is a slightly different procedure. So our equivalent resistance is equal to 1 over resistor 1 plus 1 over resistor 2. And then take the inverse of that. So 1 over everything in the parentheses. Now this is a formula that's going to be used very often, so this is a very important formula to memorize when performing circuit analysis. This formula is simplified. It will simply read as such. So this might be a formula that you might see used often. This is how that formula is derived. So now going back to our previous example. Now once again, when solving for the equivalent resistance across parallel resistors, we're going to be using this new formula given to us right here, is equal to 5, the inverse of 5 over 6 ohms, which is equivalent to 6 over 5. Now when solving for our current, as we remember from earlier, our current is equivalent to our voltage drop divided by our equivalent resistance, right? So our voltage is 10 volts, and our equivalent resistance is 6 over 5 ohms, which can, in other words, be just given as 8.33 amps, or it could be given as 25 over 3 amps. Thank you.